All right, so we are going to start looking at how electrons will be used as sources of ATP and how electrons itself are produced. So in cellular respiration, glucose and other organic molecules are oxidized in a series of steps or stages. Each of the stage, electron travels through them. And I told you already that when electron moves, what moves with it? Heat. And heat is H plus, which is proton. So when electron falls, heat will be released. It's just like if you spark a fire, the fire is the electron. The fire will produce heat as well. When you want to cook in the house, you don't intend to heat up the whole house. You only intend to cook. But the cooking will obviously generate high temperature in the house. So anytime electron falls, heat follows. So H plus an electron makes hydrogen. Again, anytime electron falls, heat follows. Now, hydrogen atoms are usually first passed to electron carriers rather than directly to O2. I'll talk about that together. So NAD plus, which we call nicotinamide adenine dinucleotide, is a coenzyme that functions as electron acceptor. So in the course of conversion of glucose to another molecule or to another form of energy, it will be released. Just like what I'm doing as I'm teaching now, I'm expected to generate heat. The electrons that are released, and I told you heat and electron work together. When electron is released, heat follows. Anytime I'm converting a form of energy to another, electron is released. When electron is released, heat also follows. So those electrons, are we going to waste them? No, we are going to keep them and trap them somewhere. They are as powerful. It is like let's say, for instance, now you do this. You know how you set your account that if you spend $1.50, that 50 cents to round off the money should automatically goes to your savings, something like that. Now, those 50 cents, 20 cents, 10 cents that goes to your savings may be insignificant today, but by the time you pack it together, it's going to make a lot of sense, right? That's the way electrons that we have here may look like. It may look insignificant the time we are saying we are making electrons and we're going to keep them, but later it's going to generate a lot of ATP. So now, we call NAD plus the first electron acceptor, and I want you to keep that in your notes. The first electron acceptor is NAD plus. Those are questions you're going to see on your exam. The first electron acceptor is NAD plus. It's a coenzyme that functions as electron carrier. So it's going to accept the electron. So this is called electron acceptor. And then it will accept electron. Now, listen again. When electron falls, what goes with it? Heat. So anytime you see E minus, which is electron, what are you expected to see close to it? H plus. And when H plus and electron moves together, if electron is falling like this now, and H plus follows, what is it going to make? It's going to make an hydrogen, which is exactly what I showed you here before. I will draw it again here. It's hydrogen, H plus E minus gives you hydrogen itself, hydrogen atom. So when we say that electron is lost, and anytime electron is lost, heat follows. If heat and electrons are following each other, then they are actually making hydrogen. So now look at what is going to happen here. In this case now, for instance, electron is going to be lost here in this reaction. And NAD plus is there to accept the electron. What's going to happen? the electron that dissociates here is actually going to form H. And you see that at the end point here, when we say NAD plus accept electron, it will accept electron. Accepting electron means reduction, because electron is negative, and when you receive negative, you become reduced. So when NAD plus receive electron, it become reduced and become NADH. So again, look at this. This is actually what I'm talking about. So the first electron acceptor is NAD plus. That's what I mentioned earlier. The first electron acceptor is NAD plus. NAD plus is the first electron acceptor in the whole cycle of cellular respiration. So now, once NAD plus receive electron that break down from here, is going to receive it and it will become NADH. It does not become NAD then electrons. No. I told you when electron falls, hydrogen ions follows, which is it. This is what we call it. And if an electron makes hydrogen atom. So in essence, when we say an element gains an electron, then we are going to put H here. Now this now has become an electron carrier. This is electron acceptor. NADH is electron carrier. So we say that NADH has been reduced. Why? Because it is now carrying electron. And that is logical, because now H was not here before, and we know addition of H means reduction. Does that make sense? So once NAD plus accept electron, it then become NADH. Now, this we call it electron acceptor. This we call it electron carrier. And of course, like I said, H has been added, and we know that when an element gains H, it has become reduced as well. So that fulfills the concept of reduction. So if I ask you, what is the first electron acceptor? The answer is NAD plus. And the full meaning of NAD plus is nicotinamide adenine dinucleotide. Now, what is the implication of this NADH, which I'm going to be explaining later? This NADH is a potential energy. It is not ATP, but it has potential of making ATP. It's like a share that you are holding in your hand, or like a check that you are holding in your hand that has power to buy you gas at the gas station, but no one takes check to the gas station to buy gas. So NAD plus is a potential energy, just the same way your check is a potential currency. It can buy you gas by the time you convert it to actual currency or you put it on your card. But as a check that it is, it's money, but it cannot buy you gas. It's not going to buy you food at McDonald's. McDonald's doesn't receive check. So now, NAD plus, NADH is a potential energy. It's carrying the energy, but it's not the energy. So NADH has capacity. Keep that in your notes. You are not going to miss that on the exam. NADH can give you 3 ATP approximately. Keep that somewhere. NADH have capacity to generate 3 ATP. It has capacity to generate approximately 3 ATP. Now, I say the word approximate because this is a chain of reaction. It may not always give you 3 ATP, but approximately it will give you 3 ATP. One NADH will give you approximately 3 ATP. So if you have 5 NADH stored at the end of the system, that means you are going to have about 15 ATP. All right? That's just to show you what it is. All right. So NAD plus and NADH, just to show you the cycle again. enzyme called dehydrogenase remove a pair of hydrogen atom, 2 electrons and 2 protons. Does that make sense now? 2 electrons and 2 protons simply means you are going to have this. It means this. Now, look at this. Look at this. A pair, I'll make this a formula for you now. See, a pair of hydrogen atom means 2H because H is hydrogen atom. So 2H, and see, we now describe it that 2H means, it means 2H plus 2E minus. So if I lose 2 electrons, that means I'm going to have 2 hydrogens. So in essence, so the 2 electrons and 1 proton is transferred to NAD plus, and then it forms NADH. The other proton is released as hydrogen ion into the surrounding solution. All right, so this is what we are talking about here, that when you have this here, NAD plus is right there, waiting to accept electron. We call it electron acceptor. Then this guy comes here, and now you have 2 electrons and 2 hydrogen ions, and then it goes ahead and join with NAD plus to form NADH. This is now called electron carrier. It's carrying electron now. It's no longer electron acceptor, it's now an electron carrier. So NADH, we say that NAD plus has been reduced to NADH. So NADH is a reduced form. NAD plus is an oxidized form. All right, we are getting to point out few things that I've talked about earlier now, just to highlight it. So if NADH transferred electrons directly to oxygen, energy will be released in one explosive reaction, and that's going to be a problem. Now, instead, the cellular respiration using an electron transport chain. If you are outlining your PowerPoint now, I will say underline this statement because I'm going to come back to it much later. Much later, I will say underline oxygen here. Now, the reason I say you should underline it is this. I told you the first electron acceptor is NAD+. The final electron acceptor is oxygen. Take note of that, please. The final electron acceptor is oxygen, and it is right here. You see the oxygen right here? That's the final electron acceptor. It's the one that will receive the final electrons. So NAD+ is the first electron acceptor. Oxygen is the final electron acceptor. And this is going to generate water, which is what you breathe, part of the product of cellular respiration. I will talk about that. Now, so in essence, we could have made electrons in the process and send it directly to oxygen, but it's going to be a problem. It's going to be explosive. So instead, there's going to be what we call electron transport chain. This transportation mechanism will be used to transport the electrons so that the electron does not cause an explosive reaction. So to break the fall of electrons to O2 into several energy releasing steps. And those are the steps we'll be talking about later. Electron transport chain include different proteins that are arranged for electron to pass through before they get to oxygen to prevent the explosion. Now,